Yes, so today we're discussing fast HTML. So I'm going to start with a general description and reviews that I think is valid, and then move on to a introduction with example application from HTML to see what's special about this framework. And then, if possible, then I will also show the demo for the chatbot that is already created by modifying the example a bit with ChatGPT instead of the other like SDKs. Okay, so here's my slides. It's already available on the GitHub. And the first one, so before we get into fast HTML, I would like to talk about a traditional approach to kind of understand what's the inputs and outputs and what's the whole process of web development is going to look like. And so traditionally, the web will be um, made of two main components, that is the back end and the front end. So it's possible that you can have either one, but usually for a dynamic website, so a website that generates output, that generates data specifically for one user and from their own interactions. So it's called dynamic, and it's different from the static website, which is the same for everyone else. So for the dynamic website, you will need two parts, that is the back end and the front end. So usually we start with the back end. So the back end is going to be where the database is stored and also where the computation takes place. So computation like a long process of let's say machine learning models and something like that. So usually they are like finished or like completed in the back end side. And from these, we kind of design the endpoints, which are actually kind of a way that the user or the client can give commands to the backend. And then from the endpoints, we usually use frameworks or SDKs to actually create the code, so develop the code and develop the app. So some popular framework include Node.js, Django, or the one that we're using is Fast API. And then from these, like from the actual application, you will have the output of each of the endpoints, and the output is usually of format text, and JSON is the most popular one. But of course, you can also have like file streams and other types of outputs from one endpoint. So that's from the back end side. And from the front end side, you start with the most basic one, that is HTML, CSS, and JavaScript. And from then you can like learn to use frameworks. So these are kind of like wrappers around those basic elements that compose of the website, and it makes a lot of more like built-in functions and a lot of more like already developed hooks in order to make your interactions more diverse. And then you will have if you use the framework and you finish the kind of the template and the working front end, then you can use like the backend APIs to create dynamic interaction. So it means that you retrieve the data from the backend, and then you use that data to fill in the empty blank spaces that your data should be inside of these like web files. And then it will create from these templates and then the dynamic data. You will have the user side files. So the like one deployment computer will send the template plus the data to your own browser. So your own browser will have its own version of the side files, and these files are the one that the browser can understand and interpret, that are HTML and CSS and JavaScript. So I will talk a bit more about the API endpoints because this is going to be relevant when we go to fast HTML. So the endpoints are kind of addresses or commands at which you communicate with your backend server. So you will have the inputs, you will serve it the inputs in the form of like headers. You set the headers, you set the path and query parameters. And the most like powerful form of these is the request body or the payload. So it's going to be the like formatted data in a JSON format. And then you will send these inputs into the API endpoint. So the API endpoint is comprised of the URL itself. So it's kind of like a path. And then the method that you're using. So the method is such as get the file, post a data, put inside an existing data, patch, and all of those methods. The outputs are usually of like comprised of two parts. So you have the status code, which is going to tell what's your status of this operation. So for example, the 200s, 201, and those that start with 200 is going to be kind of a success status code. So no error occurs. If it starts with like 400 something, then it's going to be a client side error. So maybe the client give bad inputs, and if like it's 500, then it's going to be server breakdown or something like that. And apart from the status code, you will also receive a raw information. So these are like just raw information in JSON format, text or file streams, and these are going to be sent to your client. So the client here can either be the user themselves that is actually calling the backend, or it can also be the front end that is retrieving data from the backend. So here is an example of the endpoints. So this is the one that I take from my from our redoc of the studio. So here, as you can see, it is the post method. It's oh sorry, I should start with the input. So the input is the payload in this case, and it's comprised of fields such as email, passwords, and names, phone numbers, information for registration. And then it's going to be sent to the URL API/auth/register. And the method is going to be post. So creating a new user. The output is going to be the responses in this picture. So it's have multiple responses. So you can have like 201. So that means user registered successfully. You can have like 400, which means like a registration failed, or like 423, which is invalid registration information. And the like down in the response sample, you can actually see the kind of accompanying JSON outputs if you have a success. So it will print out the all of your registration information. So now we move on to a more like an also important topic. If we want to migrate to fast HTML, that is the client side HTML. So usually when we're developing the front end, the code from the developer side is considered a template, and it's going to be deployed on a like cloud machine somewhere. And this template, it has usually have some empty placeholders for the variables or for the dynamic data to be inputted into. So the template is going to be copied and modified according to the dynamic data and then distributed to each of the user's browser. In that process, between that process is going to be the server integration or integration with the backend side. So it will retrieve the raw data from the server. So most commonly is in a JSON format, and then it fill in those data to the placeholders of the template. Then it will create a file that is already like everything is already filled and complete, and is considered now static file. And then those files are going to be sent into your client machine, and it's going to be readable by the browsers because it only comprises of HTML, CSS, and JavaScript. So it's going to be readable by the browsers, and it will generate the UI. Okay, so the fast HTML is the way that they kind of merge the back end and the front end into just one single component. So it's kind of a it uses an API driven approach. So it defines the interactions with the users from both the like computational side and also the interaction UI side with the API endpoints. So both of them are going to be defined with APIs. And then these endpoints, these endpoints don't send the usual JSON format or raw information, raw data, but they send the rendered HTML instead. And then if like you need to like update, then you're going to have to use like it support HTMX for partial updates. And is so like all in all, it's going to be API driven and simpler on the client side for the front end. So this is an example code of a very simple code. So here, as you can see, it first define the router or the API endpoints, that is get, and then just slash, just index, and the returned value is HTML format instead of the usual JSON or text. So here is the interaction workflow of your fast HTML app. So first, the user will access your website, and the website, it has a URL. So it's going to be interpreted as a as accessing the get endpoint with that URL. So the get endpoint, for example, you can see the like code here, source code here from fast HTML is going to return the UI content. So it's going to return the HTML content. And then the full page is going to be rendered on your browser because it's already in HTML. Then the user is going to interact with this they're going to interact with this UI, and then they can send back information with forms or buttons or any interactive, but usually form is the most powerful like method for sending those information because it can access with field and stuff. You can will see later on with the demo. And the app itself is going to compute and save the results if you're operating with a database. And then it will return the new UI content. So again, it's in HTML format. So for updating, it will modify the UI content, so HTML, of the indicated targets, not the whole page. Of course, if you switch page, then it's going to render the whole like new page. But if it's like in this case, you can see that it's only targeting just one element, then it's going to just modify the content of that element. And it will re-render the targets on the browser. So the reason that I mentioned that is also like because that's one of the main selling points of fast HTML. So first, it is going to be lightweight and it's very easy to set up because it's mostly operating on HTML, CSS, and JavaScript. So it's not really a big problem to worry about like compiling issues or downloading issues. It's very lightweight and easy to set up. And then because it's only rendering just partial data, partial UI content, and it's also using just HTML as the basis, so it has a very high rendering speed. Another like general advantage is that you will have a compact single component web application, so no separation between back end and front end. So it can be viewed as also like one disadvantage, but we will move on with that later. So and then you will have, in theory, full UI customization. So why I said like in theory, this is because you're only operating with low level codes for the website. So it means that it will require much more like skills on that side, which are those skills that usually people are not accustomed to because they usually use the frameworks, for example. So it might be more difficult to just migrate back to just single like low level HTML files. So that's like one of the main disadvantage, that is the lack of built-in components and state management options. So those often come with the frameworks such as React, Angular, and even Streamlit. They all have built-in components and state management options that have already abstracted multiple logic on this side, so it's easier to develop from there. Then it also has, again, because it only one component, it has low reusability without the intermediate API raw data. So if you have a raw like a backend, separate backend server that runs with that returns raw data, then you can have multiple different platforms of your front end. For example, you can have the web front end, but you can also have the SDKs. You can also have the, for example, mobile UI. So so if you are planning to use multiple devices or platforms like that, then this might be problematic. And the last one is related to the stage of development. That is, this framework is quite new, so it has a small ecosystem. So there are not a lot of packages supporting libraries or just support in general yet. So now, because we're mainly Python developers, so we'll compare the fast HTML option with the like other frameworks that we're just using for the studio and for everything so far. That is the Streamlit plus fast API. So here, the first kind of like main category of comparison is the usability. So what uniquely does each of these platform uh, offer or perform better than one another? So Streamlit plus Fast API is going to be very powerful for data-driven applications. This is because they're mainly, again, targeting Python developers and data scientists in particular. So they are mainly like developing their components around data exploration. So they have excellent support for data interactivities and utilities such as like interactive data frame and plots, charts, dashboard, something like that. They have multiple built-in components and, of course, state management for those options. They also come with default styling and structures, so we don't really need to spend time on customizing the styling or just modifying the structure in general. And because they use separate front end Streamlit and Fast API for backend, they have reusable backend APIs. Now, for fast HTML, they are better for general purpose web app, And their one big advantage is that they have high rendering speed, much higher than Streamlit, because Streamlit is running on their server. They have to compile everything at the start, so they're quite slow. And fast HTML is considered very fast in general for the web development framework. And in theory, again, it is highly customizable UI and very flexible structure, because in theory you have full control and you can code anything. You can change any like display or visual appeals. So that's also one advantage, or like possible advantage, is that even though you're going to spend more time working on the styling, you can customize the styling and it may end up much more visually appealing than the Streamlit version. And it also comes with a flexible bootstrap option. So what it means is that even though Streamlit has a mobile like a version of your own application, it's not as flexible as what fast HTML can do. And if like the user is accessing from, for example, the mobile, where the viewport is very different, then fast HTML will provide more options to configure these different devices viewports. And last thing is that it has a, I don't really know how to explain this, but the HTML file itself of fast HTML is much easier to interpret and easier to understand. You can also set custom headers for it. So the result is this is very important. It's going to have high visibility if you are using Google search, for example. And this is not confirmed, not only like it has high visibility in comparison to Streamlit, but in general fast HTML will have like high visibility for like the in the like general grounds of web development frameworks. Now we go to the comparison on the development perspective. So how easy they are to develop. So Streamlit plus Fast API is going to be very easy for Python developers and non-experts, or Streamlit in just particularly is going to be easy for Python developers and non-experts. So that's because, again, they have built-in components and state management. They also have a quite developed ecosystem, so a lot of support from the community. And because they are using Fast API as the backend, so this method will have high integrations with other platforms. So, for example, uh, the open documentations, redoc, are already available as part of the Fast API development process. In terms of fast HTML, the development is going to be like easier if you have full control of the UI elements and structure. This is because it's quite understandable and it's quite easy to monitor and also to debug. So it also have straightforward testing process rather than the Streamlit elements. And one extra note is that fast HTML may be more resistant to future updates of this library. This is because fast HTML is a very straightforward translation from your Python SDKs to the actual HTML elements. So there are not much changes in parameters or inputs or the way that they're structured or written. Streamlit, however, so the way that they code or the interface of their components may change a lot, and that might result in future like breakdowns of the service if an update is not notified or like is not updated and checked regularly. And one advantage in terms of integration is that fast HTML can actually have integration with existing JavaScripts or CSS packages for the front end. So this is very powerful because JavaScript is the kind of like the basis that many packages and libraries are built upon, and they are built to support this web development, so they're specialized for it. So if we can access and integrate with the existing JavaScript packages, then the process will be much easier. So in conclusion, I think fastHTML is a very powerful and flexible tool. So it can be used to create highly customizable and fast rendering websites. However, the problem as of now is that it puts the burden on the developers to use pure HTML and have to design them like manually the user interactions. And as a general applications of as of this moment, it is quite suitable for dynamic and small to medium scaled web applications. Okay, and that's the end of this overview presentation. I will move on to actually testing out a bit with my like with fast HTML. So here is the notebook that I use for testing out. So for the basics, I will test out the most like the advantages of fast HTML, or what's the unique point is going to be. So for starting up, I just use the import. So one like extra advantage is that the fast HTML framework support running it with a Jupyter notebook. So this is in compliance with our previous experience with NBDev, for example, and is quite useful for testing out. And here I just simply import everything from the fast HTML package. I create an application simply with this command, and I defined one simple API endpoint that is the index. So it should return a page with the title, Hello Jupyter, and then one like paragraph of text that is welcome to fast HTML plus Jupyter example. So I run this, and then for Jupyter Notebook, you will need to use this special command. It will create a server in separate thread. So by default, the server is going to be run on port 8000. So I'm just going to port 8000 here. And as you can see, it's already rendering out. So when working with HTML files like this, it's very useful to use the inspect command. And it's going to show here on the right hand side the components of this web page. So here, if you look at this body, which is the main part of your website, then you will see the H1, which is considered the largest title for HTML. And then here's the paragraph. So it's kind of an exact translation of what we already have here. And then after started this server, so this is some management. So the server can be stopped like this. And if I reload this, then it's going to again reloading and it cannot connect it. But it can also be restarted like this. So that's going to take some. This is already started. I need to, okay. All right, so here I'm going to just use a quick function for resetting app. Just use this. I think I have to stop this. Okay, and then just this.
One question.
Yes.
If you execute the function here, can it emit the HTML? Like
Sorry.
uh, if you execute the fast HTML function here, I mean that like the type, for example, titled. If
Yes.
you execute titled uh, that one in the executable column, does it emit the plain HTML here, and we can confirm what's the outcome. Yep.
It's not really that, but I think if I remember correctly, then it's going to be something like this. So page and then dot text, if I remember correctly. But
And they have some function show or something. But yeah, it's okay. Sorry for that. Yeah, but we can basically we can confirm in within the notebook, so we don't need to go to the switch back and forth with servers.
because if I remember correctly, yes, there's this 2XML page, but yes, so you can have that here.
So we don't have to switch back and forth to the browser, but we can confirm the if the function is what we want. Okay, that's good.
Yes. And so now I will move on to a custom HTML structure. So as you can see here, it's already a one-on-one kind of one-on-one translation from the as Python SDK to this file. But let's just move on with more complex structure. So the way that components are nested is that you will have a main big components, and then everything inside of that as like parameters of that component is going to be stored as children in terms of HTML hierarchical. So for example, here the UL is going to it's shortened for unordered list, and each element inside a list is going to be start with this li. So the way that it should be nested is something that looks like this. So again, the server is going to be automatically reloaded every time you update, so there's no need to restarting. But here's the updated index or get. So you can see here you have 3 elements inside of a list. And if you look at the structure here, then it's going to show that it is nested exactly the way that we define it in the using the fastHTML library. Now, going a little bit further, then we can also, apart from the structure, we can also configure the attributes of the components. So this includes very important attributes such as the ID of the components, the class of the components, or even the style of the component. So inside this updated here, I added a style for our paragraph here. I changed the background color. And I also added the attribute ID to this list. So if I run this and then I rerun the server, then you can see that it's rendered here. So this is our paragraph. So now the background has changed to a different color. And if you look inside of this like HTML file, then you're going to see that the next to the UL tag, there is this ID tag. So the ID is already updated here. Next, for the next like major selling point, you have its API driven approach. So it means that the selection on content of the render UI in fastHTML is dependent on API interactions. So for example, we can define a completely new page for our website just by adding the endpoint, for example, get, this is welcome. And here you can see that it returns the kind of similar page to our home page, but it's just a different title and different paragraphs. But I'm just going to run it here. And we don't have the like navigation button yet, but we can type it straight to our like URL like this, and it's going to show our newly added page like this. And as you can see, the introduction is now the title, and there's some different text. So we can also add the navigation links between websites just by using the elements A or like a link. So I'm just going to run this quickly and rerun it. Now you see that there is a new link appearing that is a home page from our welcome page. Then we can click that, and it will automatically runs back to the main page. And we can also navigate it from here and here, back and forth. So if we go one step further, then we can also create like a little bit more dynamic page with path parameters or query parameters. So in any way that you defined the path, you can have some like different configurations, even like some plugins, headers, middleware, something like that can also be like configured using the router. So here I modified it. I add a path parameter. So this is going to be a dynamic value. And I will say welcome, and then this name of the person that is using it instead of just welcome. So if I run that now, and now I move to the welcome page, so it's the same page, but there's this very interesting issue about it. But I'm going to show the newly added page first. So if I say me, then it's going to say welcome me. And if I say my name, actual name, like this, then it's going to show a different render for my welcome and then name. But why does like welcome or still show the old page? So it's really depend on the order at which you defined your router. So it's quite similar to Fast API in that sense, is that the order at which you define your functions or like your router endpoints is going to matter. So in this case, this comes first, so it doesn't get like overwritten by this.
One question.
Yes.
So whenever you add or modify, you haven't restart the server.
No, it's not necessary. So for fast HTML, they will have the kind of live reloading. So in essence, every time that you modify the server like this, it will automatically be updated. So every time that you have new or like new interactions, or you reload the page, then it's going to be fine. You don't have to restart the server.
That really takes care of the easy development flow.
Yes. And then lastly, you have the user interaction. So this one deals with HTMX. So as an API-driven structure, so each user interaction is handled by calling a separate API endpoint. So the result of this will be rendered on the browser. And in fast HTML, it can either render the full page or render a partial page using HTMX. So I will show two different approaches like that. So this is the first approach, that is you render a full page. So in this, I have the list of benefits, and it's going to be kind of dynamic. I will continuously adding into this list, and then it will be rendered in here. So it will be rendered in this like unordered list. So here it means that it renders each list element for each of the benefits inside of this global variable benefits. And then you can have a link to a form that is going to be the benefit form, and it's going to they're going to open a separate page that is going to be the form page. The form page, you can have the input text, which is the new benefit, and then you can submit it with this button here. And the action is going to be the like accessing the form post method. So that's the last API endpoint here. So this last method is kind of create, like it's kind of just add the new benefit string into this existing benefits list, and then it just return the newly render. So it's going to render the index page again with the new list. So one note here is that you can see here that there's no path variables. So instead it's going to look for query parameters, or it's going to look for the most commonly is the corresponding name inside of the submitted form. So here this input has the name benefit. So it means that this benefit argument is going to be extracted from this input. So it's quite like it works like that. So let me just run this. And if you look, just go back to our main page. Here you can see that it's still the same elements. So 3 elements here. Now, if I go to benefit form, it's going to change the URL. So I'm going to a different page. And here I fill in this form. So it uses HTML. Let's say that's the benefit. And if I click submit on it, then it will return to, or like in this case, it's not really return, but it's backed. It's going to render the supposed like UI of this index. But here, as you can see, the URL is not changed. But if you look at the list, is going to include the newly added one, that is, it uses HTML. However, the problem is that the list of benefits is updated using a global variable on the server. So as I mentioned earlier, the development side code is usually just the server code or the template. So the server code, it means that this variable is going to be shared across all the users. So all the users now are going to see 4 benefits instead of the initial 3. So this is going to be a problem if you're using like sensitive data, or if you just switch browsers. It's not going to be consistent for each user. So it's really not recommended. But here the button still, again, it demonstrates how it triggers the like endpoints and re-render the whole main page. So, however, there is a kind of like better way to do this without the like benefits being updated. I'm going to show in a bit. So it's going to use HTMX rendering. To use HTMX rendering, so you should input the function or the endpoint to execute when the event is triggered. So in this case, is the method is post. So we're going to use set hx post to be equal to the function submit form, or just the path form. Then you need to set the target or the element that needs to be modified after the event is triggered. So in this case is the element, the benefit list, which is the this element here, an ordered list with the ID benefits. And so we should set the target to be equal to benefits. So the sharp shine here is actually accessing the ID instead of, for example, class. And then you need to select a change location, or the location where the change occur. So how to change the content of the target. So in this case, we need to add one new, one new um, new element at the end of the list. So we can set h x swap to be before end. So that means that it's going to render just below the last child of your target, and just before the target ends. So now I'm going to also, like, if I click reset here, again, you're going to see that it's the benefits is just keep adding up like this. So it's really an unreliable way of adding. But here you use, like, let's reset the app first, and then we use this instead. So here we're using returning, and like first you see that this list is still the same, but here at the end we don't have the link to a separate page for the form, but rather we have the form itself being inserted here. So there's no need for an extra page for the form now. So this is all of the HTMX arguments that I mentioned. And then this is the child of the form. So you can use two formats. So you can use list the child first and then the attributes, or you can use a separate brackets to list the attributes and then a separate brackets to list the child. So the child here is the same. But here in the function submit form, so you see that it's vastly different from this. So it's not appending the benefits, new benefits, to the benefits list, but rather it just returned a new list element that is the benefit with the text benefit. So this element is going to be inserted inside of the target, that is this element here, and it's going to be inserted at the end. So it's going to be the last element inside the list. So let me run this. Now it should, yes, so it's going to be rendered like this here. So again, I submit it, and you see that it uses HTMX. Again, it's automatically updated here. If we reload the page, as you can see, it resets to the original data. So the benefits is not added to the global variable, which is a dangerous action, but rather it just updates the client side interaction, client side display to add this new element in the client side. It doesn't like transform the data in the server side. So this is going to be quite faster, and it's going to be like safer way.
Also quite useful for us to make the chat interface, because the contents is going to be the user specific, but most of the things we don't need to save and no need to share. But probably some few things we need to register to keep it, but mostly we don't care about the most of the conversation. So that's really convenient for us as well.
I would say that it's unfortunately, I think we need to save the previous messages, but we don't really need to kind of use the global variables. We need to save it in order to, have a continuous flow of conversation. But I'm just going to demonstrate that real quick. So again, these are the main interactions of or like unique points of fast HTML as a framework. And here is our chatbot application. So I just mostly I modified it slightly from the example app to adjust with the ChatGPT UI instead. So first I need to close this port because it's still running. So I need to close this with server stop like this. And now it should not be running anymore. Yes. So now I just opened a new app here. So first, these are some like, again, the headers. So if you look at this, you see that they are scripts and they have this source right here. So it's actually like meaning that we are importing from the prevalent Daisy UI, and of course, the most importantly is the Tailwind CSS for this. So this demonstrates one of the advantage of fast HTML, that you can use existing powerful JavaScript CSS packages. And here I will run this, and of course, this is some like Tailwind CSS setup. And I run the server as usual. So if I rerun this, then it's going to say 404 not found. This is because I have not set any endpoint. I have not implemented anything yet, but it's still going to be accessible. So here I set up the ChatGPT. So I just use my API key with organization and project. Probably we should set a new one like for the common project, but I'm not sure how yet. So here's the function, simple function to generate the response. Note that here we're using this model GPTO mini, and then we can set some variables. But the important part is the messages here. So the format of the messages that is inputted is going to be a list of JSON objects like this. So it's kind of like it has one object is going to have the role and the actual message, or the content. No, the content instead. So the role is usually is either user, or it's going to be assistant. It also can be the system at the start. So these are the roles, and then the content is the actual message. So here I'm returning, the prompt should be of that format. And then I'm returning the choices, like the first message and the content. I just strip that to return just a single string message. Then I define the chat component. So instead of creating like putting everything inside of like the router endpoint itself, I just create some smaller component in order to return this HTML structure. So here I start with the chat message. So it's either going to be like you have the message, and then you have the indicator of whether they like the owner of this message is a user or something else. So if user is going to be true, and if something else is going to be false. And then here are some like a dynamic computation to set the class. So it, because like we're using existing CSS file, so we can set the different classes in order to render them differently in terms of the style. And then here, the component chat itself, you have the role and you have the message. But here is the also a very important part. So in here you have the hidden, and then you have the name itself. So hidden is going to be kind of like not rendered, but it's going to be there. So it's like it's useful for later on when we're trying to submit the past messages to form a good conversational flow. So here I save the message to the name messages. So there can be multiple things saved to this name messages. So in that case, it's going to be like interpreted as a list of all of those elements. And similarly, I save a corresponding variable that is the role, so user or assistant, to the name roles. And then apart from this chat message, I'm going to need a chat input. So this is my chat input. So I just set the input and then placeholder, and the name is just shorthanded for message. And one important here is that you have this HX swap and OOP. So OOP stands for out of bound. So in case that we need to modify more than just the target variable, sorry, the target uh, like value, then we can use the out of bound to modify like all the elements next to it or like before it or like just adjacent to that. So in this case, this chat input is also going to be modified every time that the form or something of a new chat is submitted, not just the chat list, but also the chat input. So the reason is that we need to also remove every input from the input field of this chat. And then you have the main page itself. So I put here the biggest element of this page is going to be a form. So the reason is that the form here also contains the chat list here. So this chat list is going to contain the hidden messages and hidden roles. So in this way, we can save all of the past messages in order to input into our GPT model for a conversational flow. And it starts with a single chat message like, hello, I'm a chatbot. How can I help you? And um, under this chat list is going to be the input form here. And it's going to have a group with a button that is sent. So this button will obviously submit this form. And where do we submit it is going to be a we're going to update it with HTMX, which is going to be target is send operation send, and target is the chat list or this list here, this element here. And swap is also similar to the one that we have, is a before end. So we put the new message at the end of the chat list. I'm just going to run all of this. And then the form submissions that we have here is going to be the function that we are going to use. And send here, we have the new message. We have the existing message, which is going to be interpreted, as I mentioned, a list. And then we have the corresponding roles. We then form this prompt by using the, we input all of the roles and content with using the roles and messages. And then finally, we add the new message, the latest message. And we're going to put this whole conversation as the prompt for ChatGPT to create a new output. And then we return, what we return is going to be inserted at the end of the chat list. So that's going to be number one is our chat message from the user. And number two, the chat response from ChatGPT. And lastly, the chat input, which is, even though it's out of bound, it's just right underneath it. So we already set the out of bound swap to be true. So it's also going to be re-rendered. Yes, okay. So now if I reload the page, hold on, it's going to take some time. Yes, it's going to show the UI here. So again, this is our first message. And let me just write something like ask them to, let's say, write a poem. Oh, sorry. Wait, I just forgot how that. Never mind. Yes, so it's going to show like this poem right here. So I need to let's say that I want to change something from this. So in order to answer this kind of like, if I say I don't like the word the phrase flower stretch, change it and rewrite this poem, keep everything else the same, for example, then with this prompt, it's going to need to know what's the previous messages are going to be in order for it to flow as a conversation. So now I'm going to send a message and then test it. Okay, so here's the new one. So as you can see, everything is the same except for the last phrase, which is wildflower stretch. Now it says wild blossoms bloom. So this means that it already, like, our system of saving the previous message to form a conversation is already successful. Yes, so this is what I got so far with the chatbot. And probably that's the end of this presentation.
Thank you for the presentation. I'm going to stop recording now.